Good morning to one and all. In this video I am going to discuss about cubes and cube roots. Okay, so in that cubes and cube roots, in the concept 1.4 we are discussing now. So in this I'm discussing with you that descriptive questions Ncert. In that first question we have, which of the following is not a perfective cubes, they asked. So generally, we should know at least 10 perfective cubes we should know. So then we can identify easily among the given options which is not a perfective cube. Okay, see, we know that is the 10 perfective cubes are 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125, 6 cube is 216, 7 cube is 343, 8 cube is 512, 9 cube is 729, 10 cube is 1000. So these 10 if you learn easily, so we can solve the remaining sums very easily. So first option, so 216 is a cube of 6 cube. Okay, 216 is a perfective cube, it is a cube of 6. Okay, next 1000 is also perfective cube, it is a cube of 10. And 4656, 46,656, it is a perfective cube or not, let us see. Okay, we can do this is by using prime factorization. Yes, see, 46,656, so we can divide. So 2 2s are 2 3s are 2 3s are 2 2s are 2 8s are, again 2 table, 2 1s are 2 1s are 2 6s are 2 6s are 2 4s are, next 2 5s are 2 8s are 2 3s are 2 2s are, next again 2 table, 2 2s are 2 9s are 2 1s are 2 6s are, again 2 table, 2 1s are 2 4s are 8, 1 1, 2 5s are 10, 2 8s are 16, next 2 7s are 2 2s are 2 9s are, so this we can write. And 3 table, 3 2s are 3 243s are 3 81s are 3 27s are 3 9s are 3 3s are. So the prime factorization of the perfective cube is we can make in every, so the prime factorization of perfective cube is in the group of 3. Okay, so 2 into 2 into 2, how many 2s? 1 2 3 4 5 6, so into 2 into 2 into 2, and 3 into 3 into 3 into 3 into 3 into 3 into 3. So now it is we need to make a group of 3 similar factors. So in each group we need to take 3 similar factors. So in this is one group we have, here also one group we have, here also one group, here also one group. So these and all. So if it is no number is left over, so then it is a perfective cube. Okay, so in each group 3 similar factors we have, so no other extra number we have in this prime factorization. So then it is a 46,656 is the perfect cube. Next 128, if you take 128, let us see, 2 6s are 2 4s are, next 2 32s are 2 16s are 2 8s are 2 4s are 2 2s are. So write down here how many, 1 2 3 4 5 6 7. So 1 2 3 1 2 3 2. So how many we have? 4. So this is one pair, this is one pair. So it is in the prime factorization, it is this 2 does not have the group of 3. So now this is not a perfect cube. Here there is no number without group. Okay, all are in the group only. Here this 2 is not in the group of 3. So now it is 128 is the not a perfect cube. Okay, next question. Now I am going to discuss with you second question. Find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. So the given numbers are not a perfect cubes. So we need to, if you multiply these given numbers with some other number, then it becomes a perfect cubes. So those numbers we are going to find. So this, for this perfect cubes to be multiplied, to be divided means we need to be multiplied or to be divided. for this type of questions we should use prime factoration. Okay, in the squares and square roots also we used multiplication and division. For that type of questions we used their prime factoration. Similarly here also we should use the prime factoration method. Let us do here. So 2 128s, 2 64s, 2 32s, 2 16s, 2 8s, 2 4s, 2 2s. So write down here. So 1 2 3 1 2 3 1 2. So 8 we have. See here. So make every 3 similar numbers, make a group here. This is one group, here this is one group, here these two, here in this group only we have 2. Okay, so to make a group, how many 2s we need? We need one more 2. So that means if you multiply the 256 with 2, then it becomes a perfect cube. Okay, here in this group we have only 2 2s, so we need extra 1 2. Okay, so that if you multiply extra 1 2, if you need means we need to multiply with 2. Okay, so therefore if you multiply 256 with 2, then it becomes a perfect cube. Then it becomes perfect cube. Okay, next question. 392. So do the prime factoration 392. So 2 1s are 2, 2 9s are 18, 2 6s are 12. Next 2 8s are 2 9s are 18, 2 8s are next 2 49s are 7 into 7. So that is we can write as 2 into 2 into 2 and 7 into 7. So these these 3 2s we can consider as one group. Here these 7 and 7. So how many is this? We have only 2 7s only. So in each group we need three similar factors, but here we have only 2 7s. How many 7s we need extra? 1 7. So to make a group we need 1 7 extra. So that means if you multiply, okay, therefore if you multiply, if we multiply 392 with 7, then it becomes a perfect cube. Then it becomes a perfect cube. Okay, next question. 675. So do the prime factoration for this. 5 1s are 5, 1 7, 5 3s are 15, 2 5, 5 5s are next 5 2s are 10, 5 7s are 27. Next 3 9s are 3 3s are. So make a pairs 5 into 5 and 3 into 3 into 3. So make a group. So identify the groups. So these three have one. These 3 3s as one group, and these 2 5 how many we have? Only 2. So we cannot make a group. So to make a group, how many 5s we need extra? One more 5. So if you multiply with 5, if you multiply 675 with 5, then it becomes a perfect cube. Then it becomes a perfect cube. Okay, next question number 243. So do the prime factoration for the 243 here. 381s, 327s, 3 9s, 3 3s. Okay, so write down here. So 3 into 3 into 3, 3 into 3 into 3. So this 3 has one group, and here we have to make a group. We have only 2 2s. So but how many we need? 3 3s. We need 3 3s. So to make it is a perfect cube. So to make a group here, we need one more 3 extra. That means if you multiply, so therefore if you multiply 243 with 3, then it becomes a perfect square. Then it becomes a perfect cube. Perfect cube. Okay, so in this way. Now I am going to discuss with you third question, that find the smallest number by which each of the following numbers must be divided to obtain a perfect cube. So the given numbers are not a perfect cubes. So if you divide the given numbers with some number, then it becomes a perfect cubes. Let us see. So for this method also we should use prime factoration method. See, 128 we can do the divide. So 2 6 are 2 4s are 2 32s are 2 16s are 2 8s are 2 4s are 2 2s are. So write down here. So 2 into 2 into 2 into okay. So make the groups for every 3 similar factors. So these 3 2's has one group, these 3 2 has one group. So here we have 2 is ungrouped. Okay, so here the 2 is in the ungrouped, there is no group for this 2. So if you eliminate these 2, then it becomes a perfect cube. Okay, that means eliminate means we should divide. So therefore if we divide 128 with 2, then it becomes a perfect cube. Okay, next question. 53,240. Let us divide in the 11 table. So 11 ones are 11 fours are 44, and here 44 9 2 11 8s are 88, and 4 4 11 4s are 44 0. Again 11 table. So 11 4s are 44, and 11 4s are 44 and 0. Again 11 table. 11 4s are 44 0. 11 40s are. Next 5 table. 5 8s are 40. Next 2 2s are 2 4s are 2 2s are. So right now the prime factors here, 11 into 11 into 11, and 5 into 2 into 2 into 2. So make a pairs, make a 3 numbers as one group, make a groups here. So these 3 2's have one group. Here 5 is alone we have, it is not in the group. Okay, to make a group we need 2 5's extra, but here we need to divide. If we eliminate this 5, that means if we divide with 5, so the remaining factors in the groups, so then it is a perfect cube. Okay, if the prime factoration of a number is in the group of every 3 similar factors, okay, then that number is, we can call a perfect cube. So here 5 if we eliminate means then the remaining factors, remaining prime factorization is in the form of group of 3 similar factors. So therefore we can write, if we eliminate, if we divide 53,240 with 5, then it becomes a by 5, then it becomes a perfect cube. Okay, next third question we have, that 2 9s are 2 96s are 2 48s are 2 24s are 2 12s are 2 6s are 2 3s are. So make a pairs here, 2 into 2 into 2 into 2 into 2 into 3. So make a groups. Here this is one group, these three as one group. Here we have 3 is extra. Okay, so if you divide this 3 by, if you divide 192 with 3, then it becomes a perfect cube. Okay, see here. So therefore, if we divide 192 by 3, then it becomes a perfect cube. Okay, next question. 704. So 704 is do the prime fraction. 2 35s are 2 2s are. Next 2 1s are 2 7s are 14, 2 6s are. Next 2 8s are 2 8s are. Next 2 44s are 2 22s are. Next 2 11s are. So make a group right here. 2 into 2 into 2 and 2 into 2 into 2 into 11. Okay, so make a groups for every 3 similar factors. So these 3 has one group, these 3 has one group. So here 11 is extra we have. So if you eliminate 11, that means if you divide 704 with 11, it becomes a perfect cube. So therefore, if we divide 704 by 11, then it becomes a perfect cube. Then it becomes a perfect cube. Okay, discuss with you question number 4, that Parikshit makes a cuboid of plasticine of 5 sides 5 cm, 2 cm, 5 cm. How many such cuboids will be need to form a cube? Okay, so here Parikshit make a cuboid. Okay, those measures are Parikshit make a cuboid. Okay, so which is as a sides 5 cm, 2 cm breadth and height is 5 cm. To make a cuboid, how many such cuboids need to form a cube, they asked. So first, what is the volume of the cube? Volume of the cuboid equal to length into breadth into height. So that is 5 cm into 2 cm into 5 cm. 5 2s are 10, 10 5s are 50 centimeter cube. So how many such cuboids? So suppose if one cuboid volume is 10 centimeter cube, means 2 cuboids equal to 1 cuboid volume is 10 centimeter cube. Then 2 cuboids volume equal to 10 into 2. So the multiple of this 10, it becomes a cube. So 10 into 2. Sorry. Okay, so 5 centimeter into 2 centimeter, 10 5s are 50. So 50 centimeter cube. So the required cube is becomes to the multiple of this 50 centimeter cube. Okay, so to make a pairs, so in the perfect cube, okay, so the prime factoration of the perfect cube, the prime factors must be in the groups. Okay, for every 3 similar factors we consider as one group. Here these 2 and 5. So 5 has 2 2s. How many 5s we need? One more 5 into 5. And 2 has only 1 2. So how many 2s we need more? 2 2s. So if you multiply with 5 into 2 into 2. So 5 4s are 20. So that means if you add 20 cuboids like this, then you will get a cube. Yes. So therefore, so 5 into 5 into 5 and 2 into 2 into 2. So then it becomes a 1000 centimeter cube. That is 1000 centimeter cube is nothing but 1000 is the perfect cube. Yes. So to make a perfect cube from these cuboids, how many number of cuboids we need? 20 cuboids we need to make a cube here. Okay. So next question. So find the cube root of the following numbers by using the prime factoration method, they said. So this question we can write as, so do the prime factoration. So 2 5s are, 2 3s are, 2 2s are, 2 4s are. Next 2 2s are, 2 6s are, 2 6s are, 2 2s are. Next 2 ones are 2 threes are 2 threes are 2 ones are. Next 11 table, 11 ones are 11, 121 are 11 into 11, 11 into 11, 121. So do the prime factoration here, write the prime factoration here. Prime factors 11 into 11 into 11. So in a perfective cube, every three we have to make every three similar numbers as one group. From every one group we need to take one number. So in 2 into 11. So 2 into 11 is 22. So therefore cube the root of 10,648 is equal to 22. Okay. Next number. 2 6 are 12. 2 9s are 18. 2 1s are 2 2s are. Again 2 1s are 2 3s are 6. 2 4s are 8. 2 5s are 10. 2 6s are 12. Next 2 1s are 2 7s are 14. 2 2s are 2 8s are. Next 2 8s are 16. 2 8s are 16. 1 2 6s are 2 4s are. Next 2 4s are 2 3s are 2 2s are. Next 2 2s are 2 16s are. 2 108s are. 2 54s are. 2 27s are. Next 3 9s are. 3 3s are. So the prime factoration you can write here how many 2's we have? 1 2 3 4 5 6 7 8 9. So 2 into 2 into 2 and 2 into 2 into 2 and 2 into 2 into 2 into 3 into 3 into 3. Yes, so you can make the groups for from every three similar factors we should make a group here. These three has considered as one group. These three you can consider one group. These 3 2's you can consider one group. These 3 3's you can consider one group. So from every one group we need to take one factor, that is from these 3 2's 1, from this one group, from this group 1 2, from this group 1 2, from this group 1 3. So 2 into 2 4, 4 2's are 6, 6 3's are 18. So 18 cube. So cube the root of 13,824 equal to 18. Okay. Sorry. 8 3's are 24. So 2 2's are 4, 4 2's are 8, 8 3's are 24. So this is, so cube the root of 13,824 is how much? 24. Next, this prime factoration for this you can write. So do in the divide in the 2 table. 2 1's are 2 5's are 10. 1 2 5's are 10. 2 2's are 4. 2 9's are 18. 2 6's are 12. Next again 2 table. 2 2's are 4. 2 7's are 14. 2 6's are 2 4's are 8. 2 8's are 16. Again 2 table. 2 1's are 2 3's are 2 8's are 2 2's are 2 4's are. So in the previous question if you continue, so 1384, so it is, if you do the prime factoration same here only we can continue. So continue here same as it is. So that is 2 into 6 9 1 2 in the 2 table 3 4 5 6. If you see from this 13,804 you can continue this, you can write down here as it is. So it becomes 21728. Next 2864. 432. Next 216. 108. 254s. 227s. 3 9s, 3 3s. So if you write how many 2's we have? 1 2 3 4 5 6 7 8 9 10 11 12. So 12 3's we have 1 2 3 1 2 3, okay, into 1 2 3 into 1 2 3, okay. So now next 2 3 into 3 into 3. So make the groups for every 3 similar factors. So these 3 is one group, these 3 2s has one group, these 3 2s has one group, these 3 2s has one group, these 3 3s has one group. So from each and every group we can take one number. So 2 into 2 into 2 into 2 into 3. So 2 into 2 into 2, 2 4 power 16, 16 3 is a 48. Okay, so therefore, so cube root of 1,10,592 equal to 48. Cube root of 1,10,592 is 48. Similarly, we can do this. Okay, so 2 table if you do here, 2 8s are 16, 1 5, 2 7s are 14. Okay, 1 6, 2 8s are 2 8 zeros. Okay, next 2 table, 2 4s are 2 3s are 6, 2 9s are 2 0 4. Next 2 2s are 2 1s are 2 9s are 18, 2 5s are 2 2s are. Next 2 table, 2 1s are 2 here 0, 2 9s are 18, 1 5, 2 7s are 14, 2 6 are. Next 2 5s are 2 4s are 2 8s are 2 8s are. Next 2 2s are 4, 2 7s are 2 4 4s are. Next 2 1s are 2 3s are 2 7s are 2 2s are. Next 2 6 are 2 8s are 16, 2 6 are. Next 2 3s are 2 4s are 2 3s are. Next 7 table, 7 49s are 7 7s. So you can write here. How many 2s we have? 1 2 3 4 5 6, 1 1 2 3 4 5 6 7 8 9. So 2 into 2 into 2, 2 into 2 into 2, and 2 into 2 into 2 into 2, in 7 into 7 into 7. So we need to make the groups for every 3 similar factors. So these 3 as one group, these 3 as one group, these 3 as one group, these 3 as one group. So from each and every group we need to select one number. So 2 into 2 into 2 into 7. 2 2s are 4, 4 2s are 8, 8 7s are 56. So that is equal to, so therefore we can write square cube root of 1,75,616 equal to how much? 56. 8 7s are 56. Okay, so in this manner we are going to find by using the prime factorization. Okay, next question. Okay, now I am going to discuss with you the estimated, the cube root. We need to find the estimated method. So these, as if you want to use estimated method, so we should know the 10 perfect cubes and the cubes ending with the digits, cube ending with the digit and cube root ending with the digit. Okay, that I will share the video, that also you can watch. If you watch there, it will easy to understand. Okay, let us discuss. So in the estimated method, we should make first 3 digits as one group, remaining digits as one group. Okay, so this is a perfect cube. If perfect cube is ends with 6, then cube root also ends with 6 only. Okay, cube root of the digit ends with 6, and near to the 17, what is the perfect cube we have? 8 only we have the perfect cube near to the 17. Okay, so square root of 8 is how much? 2. So 2 6. So 26 is the cube root of 17,576. Okay, this is the estimated method we can do very shortly, and the remaining sums also. So first 3 digits as one group and remaining is numbers is one group. So this number is, this perfect cube is ends with 1. Yes, and then cube root also, if the perfect cube is ends with 1, then cube root of this number also ends with 1 only. Okay, and this 1 we have, nearest cube what we have 1, so cube to root of 1 11, so is 1331 is the perfect cube, they asked. Yes, it is the perfect cube, it is a cube of 11, it is the cube of 11. Next we can write first these 3 digits as one group, remaining digits as one group. So this perfect cube is ends with 3, then cube root is ends with 7. So this cube root, if the perfect cube is ends with 3, its cube root ends with 7. So the nearest, so remaining how much, what we have 4. So nearest cube what we have 1 only. So what is the cube root of 1? 17. 17 is the cube root of 4913. Okay. Next, so first 3 digits as one group, remaining digits as one group. Here this perfect cube is ends with 7, then cube root ends with 3. Its cube root ends with 3, and the remaining 12 we have, nearest cube of 12 we have 8. So cube root of 8 is 2. So 23 is the cube root of 12,167. Next number 768. So make a first these 3 digits as one group, remaining digits as one group. So this method, so this, if the perfect cube is ends with 8, its cube root ends with 2. Its cube root ends with 2. So nearest perfect cube of 32 is 27. Cube root of 27 is 3. So 3 2, so it becomes 32. So cube root of 32,768 is 32. Okay, in this manner we are going to find. These are the cube root of the given numbers. Now let us see 8th question. Cube root of 0.000216. So if you write in the decimal fraction, it becomes 216 by 0, 6 zeros will come, that is 10 lakhs will come. Okay, so once it will come. So cube root of this number 216 by, so 1 crore you can write 3 zeros. So here cube root of 16 is how much? Cube root of 16 by cube root of ones, tens, hundreds, 1000, 10,000, lakh. So cube root of 10 lakhs equal to, okay, so cube root of 216 by cube root of 10 lakhs. So cube root of 216 is 6. Cube root of 10 lakhs is, here how many zeros we have? 6 zeros. So you can take 3 zeros number, that is 0001. So 1000 is the cube root of 10 lakhs. Okay, now 6 by 1000. 6 by 1000, how can you write? 0.006. So therefore cube root of 0.000216 equal to 0.006 is the answer. Next, question number 9, we have that if, question number 9, the cube of a number is 8 times the cube of the another number. Okay, so if we let the two numbers are x, let the two numbers are, we don't know that two numbers, just you can consider, let the two numbers are be x and y. What are the two numbers we assumed? X and y. So one of the number is, cube of one number is 8 times to the cube of another number. That means cube of x is x cube equal to 8 times, that means 8 into cube of other number, 8 into cube of y is y cube. So x cube equal to, we can write 8y cube. Okay, sum of these two numbers, sum of the cubes of the numbers. So cube of x is sum of the cubes. How much they given? Sum of the cubes equal to 243 they given. So cube of x is how much? X cube. Cube of y is y cube. So x plus y cube is how much? 243. So what we assume, x cube equal to, we can write 8y cube. Yes. So from this equation 1 you can consider. From this equation 1, x cube equal to, can I write y? 8y cube? Yes. 8y cube plus y cube equal to 243. 8y cube plus y cube, 9y cube equal to 243. Then y cube equal to 243 by 9. So you can cancel 9 ones are 9 twos are 18. Here 6, 9, 63. 9 7s are 63. So y cube equal to 27. Then y is equal to cube root of 27. Cube root of 27 is 3. Y is equal to how much? 3. If y is equal to 3, x is equal to how much? Here. Y is equal to, from equation 1, can I write y is equal to 3 we obtained here. So x cube equal to 8 into x cube equal to 8 into y cube. Y cube is nothing but a 3 cube. That means 8 into 27 cube. Okay, 3 cube you can write. This 8 can I write 2 cube? Yes. So I am writing, simplifying this side. So x cube equal to, so that is 2 cube into 3 cube. 8 we can write as 2 cube. This x cube equal to 2 into 3 whole power 3. So if the both side powers are same, bases are equal, 2 3s are 6. X is equal to how much we obtained? X is equal to 6 and y is equal to 3. Difference, what he asked in the question, what is the difference of the numbers? So difference of the numbers equal to, difference of the numbers equal to that is 6 minus 3 equal to 3, x minus y, that is x is 6, y is 3. So 6 minus 3 is 3. Okay, so now we are going to find the cube root of a power 6 into b power 9. See, this we can write as, so I am little bit changing this. So here a power 6 I am writing as a power 2 whole cube, and b power 9 I am writing as b power 3 whole cube. That means 3 3s are 9 only will come, 2 3s are 6. The value will not change. So cube root of, so this we are multiplying a power n into b power n, we can write a power in a into b whole power n, that is a square into b cube whole power 3 we can write. Yes, so this cube root we can cancel. Left over number what we have? A square into b cube is the correct answer for this. Okay.